All right, so we're gonna film this for the class. We're gonna go through the concrete rebar problems and explain each step and what it means. So step one, what is our first step, Nelson?
Figure out the givens.
Just write down all the givens. So we're gonna write down on the PE number 1, we got 20-foot rebar lengths. The concrete is 3,000 PSI. We got 10 soldiers at 75% effort. We got an 80-foot length. And where is that? There we go. We got 80-foot length. For the horizontals, WH is number 5 rebar, 12 inches on center. That's what OC means. The WV, the verticals, are number 6 rebar, 5 inches on center. And what we need to find is the rebar schedule and determine the volume of concrete. So step 1. First thing we have to do is determine the minimum cover for the vertical and the horizontal rebar. Why do we need to determine that, Currents?
Sorry, I wasn't.
Okay, so we
I
have to have
determine it because it's going to affect the length of the rebar that you're putting in, because that's the amount of space you have to leave between the end of the rebar and the surface of the wall so that water can't penetrate and rust your rebar.
Because if rebar rusts, it will literally like break the cement apart from the inside out. So we need to know, based on the size of the rebar, how much room we need, and that's based on whether it's exposed to the elements or not exposed to the elements. So for the vertical, the number 6 rebar, we need 2 inches of cover, and for the horizontal, we only need 1.5 inches of cover.
And that's
so,
based on the table.
And it's based off of table
6-2.
Yeah, 6-2, and that's in 3-31 or 3-34.44, which is concrete and masonry. So all of the rebar stuff is chapter 6. We are dealing a lot with chapter 4 for the
For this, it's pretty much all like tables 1, 2, 3, and 4, like 6.
Exactly.
6, 1, 6, 2, 6, 3, 6, 7.
So we look it up and we find if we have vertical rebar here that needs 2 inches of cover and horizontal rebar here that needs 1.5 inches of cover, you have to give everything 2 inches of cover, because on this point you can't have 1.5 inches of cover while still giving this piece 2 inches of cover. So everything has to be 2 inches of cover. So that's just an easy look at the table, and we've got this sheet. I'll make copies of it tonight and get soft copies of it so we can distribute it tomorrow. And it's just like plug and play on this. And then, so that's step 1, determine the cover. That's a really easy step because we just look at a table. Step 2, determine minimum splice overlap. So let's just, for kicks and giggles, let's do the vertical first. How tall is the wall?
The wall is 80 feet tall.
How tall is the wall?
It's 14 foot 3 inches.
14 foot 3 inches. So when we take 20 foot 20 foot pieces of rebar, do we need to overlap them? Well, I'll get to you. We'll come back to that. So if we have,
I hate myself.
all right. So if we have a 14.5 inch wall and we have 20 foot rebars, we don't need to overlap them at all, because one piece, we're gonna have to cut it to keep it stuffed inside that wall. As far as the length of it, Nelson, how long is the wall?
80 feet.
Yes. How long is its effective length?
Buddy, I got no fucking clue.
Cool.
So the effective
Oh, bring it back. 79 feet and 8 inches.
And you got that because
Because I took 4 inches from 80 inches.
Because
from 80 feet.
Yeah, 2 inches on one side
And 2 inches on the
and
other
2
side.
inches on the other side,
It's starting to make sense.
and 2 plus 2 equals 4. So we take that, and so that's the longest stretch of rebar we'll have, is at 79 feet 8 inches.
Roger.
So anyway, so for step 2 specifically, the vertical, we're not going to have any overlaps because one piece of rebar is going to be just fine for each vertical run. For the horizontal, we're going to look up in the table which table is that? It's table 6-4 on page 162. That page number may not be right, but the table is right. We're going to look it up right there, and we're going to see that for a number 5 top bar, it's 36-inch overlap. Oh yeah, right there. Now we know that the top bar, we know that because the top bar is for 12 inches or more between the rebars. And here, bring it back over here. So if it's top bar, it can be 36 for the number 5, but 26 inches, or excuse me, 26 inches of overlap for all others, meaning less than 12 inches between
That horizontal.
the horizontal
Yeah.
runs. That's because if they're less than that, you can assume that all of the different runs of rebar are helping each other reinforce each other. And so you don't need as much overlap. Because there's 12 inches of concrete below each horizontal run, they're acting more independently and need to have more overlap so they don't rip each other apart, or the cement doesn't rip apart the rebar pieces. So we're gonna go with 36, and that's what the top bar means. You have to have 12 inches of concrete down until the next one, the next rebar run.
So moral of the story, if it's 12 or greater on center, you're going with top bar.
Because they don't reinforce each other as much.
Done.
So that's why that matters. So step 3, determine the number of pieces of rebar per run. So the first stick of rebar we stick in there. Do we overlap anything?
No.
No, because there's nothing to overlap with. And we're only looking at the horizontals right now. Now the second stick of rebar we put in there. How much has to overlap with that first 20-foot stick?
17 feet.
That's how much you have left over.
Oh, okay,
3
3 feet needs
Yeah.
to overlap.
So it's that 36-inch overlap.
Yes.
So the effective length of each additional stick of rebar is 17 feet.
Yes.
So all we do is we take 20 feet, subtract it off of that 79 feet 8 inches, and
You're gonna get 59.8.
yeah, 59 and 8 inches, not 0.8.
Yeah.
And then all we do is we just take how many times can we subtract 17 until we don't have enough to subtract fully 17 out of it.
Okay.
And how many do we get?
We get down to 25 feet and 8 inches, and then you subtract that by 17 to get 8 feet 8 inches.
Yep.
And you can't do 17 again.
So there's
So there's 4 lengths.
yeah, four full 20-foot lengths, and then one that we're gonna have to cut, and that one's gonna have, was it 8 feet 8 inches
8 feet 8 inches.
is how much it extends past that very last piece of rebar to the edge of that 2-inch cover at the end of the cement.
Roger.
So if we have 8 feet 8 inches of rebar sticking out, we have to overlap that piece 3 feet more, so that's just 8 feet 8 inches plus 3 feet, which is
11 feet 8 inches.
11 feet 8 inches. So then we just write down four runs, or 4 sticks of 20 foot, 1 stick of 11 foot 8 inches per run. Then we just move on to number 4. Step number 4, find the number of horizontal runs. So that, what we just calculated is for one length across the whole wall, but the wall is 14 feet something high, and we're gonna put these every 2 feet, or every 12 inches from the base all the way up. And so the way we do that is we find the effective wall height, which we take the given wall height, which was 14 feet 3 inches, and we subtract 2 inches, because we got that cover. And then additionally, we take 2 inches from the bottom also.
Okay.
And
Totally you subtract 4
the
inches.
one thing I haven't really figured out is, I'm assuming when they give us these rebar problems, it's only looking at the wall, and we're assuming the wall is independent of the footing.
Yes.
So everything I've seen does that, and I'm just gonna go under that assumption since they haven't accounted for that at all. So we're gonna take a 2-inch cover from the top and a 2-inch cover from the bottom. And that gives us where we, step 4, we're looking at 13 feet 11 inches of total wall height, the effective wall height that we need to cover with rebar. And we need to put a run of horizontal rebar every 12 inches. So we just take that 13, and if you convert it to decimal feet, 13.92 feet, turn it into inches because it's just going to be easier. So we multiply by 12, and then we divide the whole thing by 12 because it's every 12 inches. So I know that's a little confusing. If it wasn't 12 inches on center, we would divide by whatever that value is. And then we add 1. Why do we add 1?
Hold on.
Because if you have a box like this, and you need to put something every, however many times, every so many units of length, we're going to put 1 here, 1 here, 1 here, 1 here, 1 here, and then there's a space here where we've counted. If we just did it divided, it would have been these only. We have to add 1 for that bottom or the top run, and so we have to account for that. So the math works out to 13.92 feet times 12 inches per foot divided by 12 inches. All of the units should cancel. Feet cancel, inches cancel, plus 1 equals 14.9 runs. We can't have a part of a run, so we're going to round that up to 15 runs.